Okay, today I'm going to cover the Lab4, which is the hand operated pump, similar to, say, like a rural well pump. At this point, we've already covered labs 1 through 3, so you should have a pretty good understanding of SolidWorks. I know there's been a lot of questions in the past week which are all related to Lab 4, the pump, which is a little concerning because most of the features that you're going to use in Lab 4 are just repetition of what you've already done in Lab 1 through 3. So I suggest if you're having a hard time with this lab, if you're having a hard time doing features like the extruded cuts, revolve, go back and review the Lab 1 through 3 videos and lab manuals, because it's going to have the information that you need to do Lab 4. Every feature in Lab 4 has already been covered, aside from perhaps the threads, but everything else has already been done in Labs 1 through 3. So if you don't have a solid grasp on those concepts, the idea of an extrusion, sketches, how to work with sketches, then you should really go back and review the stuff that we've already done, because we really need to move forward from here with a good understanding of the material that we've covered in Labs 1 through 3. With that in mind, I'm just going to go quickly over how to create the parts. For those of you who are still struggling, you can consider this just further practice, but really, by the end of this lab, you should have a very good understanding of how to create these parts. We'll start with the pivot block. So we open up here a new part file, and we're going to create a new sketch on the top plane. So we'll just select top plane there. And I'm going to create a new center rectangle, place at the origin there, with a width of 150 millimeter. Remember, again, we're only working in mmgs, millimeters, grams, and second, and a height of 400 millimeters. Okay, should look like that. We'll exit that sketch. Now we'll extrude. Remember, features tab, extrude, and we'll set a blind depth of 150 millimeters, just like that. Okay, so now we've got the bulk of our block, and we're just going to make a couple cuts here. We'll create a new sketch on this top face here, right there. Okay, we'll right click the sketch, go normal 2, and now we'll create one circle here and another further down here. We'll smart dimension these to 30 millimeter diameter here as well, and then we'll pick the center of these to be 100 millimeters away from the edges, and 75 from the base, which should be halfway. As you can see here, they're already 75 because I specified them down the middle of the plane, which is 75 millimeters. Then we'll go ahead, exit that sketch, go back to features, select extruded cut. Alright, so we can see here it's going to cut through the body of this block. We're going to say blind or through all, doesn't really matter. The point is that we cut through the entire block, and press OK. So now you can see there's a hole through the entire block. If you didn't believe me, there you go. And now we will save this as the pivot block. So I'll go save as. I'm going to create a new folder. I'll create a new folder here on my desktop to place everything into. So we're going to call this Lab 4, and this is the pivot block. It's very crucial to name your components for what they are. I've seen some students name their components Part 1, Part 2, Part 3, and while you might think that's a good idea in terms of organizing your parts, what you're forgetting is that when you go to look up those parts, when you have your parts in your tree manager here for your part manager, when you're doing the assembly, it's just going to say Part 1, Part 2, Part 3. It's very hard to identify the parts by a generic name like that, so you want to name it after what it is. This here is the pivot block. I name it pivot block. When it's saved, I can find it easily in Windows. When I load it into my assembly, it's easy to identify. More importantly, when you submit your assignments, when you submit your lab design projects, the TA marking them has to know what the components are. He has to be able to find them if there's an error with your assembly, and he has to manually load your files into the assembly because of whatever. He's not going to be able to identify them based on part numbers. So save your parts by the names given in the lab manual, or of course just, use a little bit of common sense and name them after their function in the assembly. And definitely don't label them by numbers. With that as well, you should always save your parts in a folder that you can easily identify when you're going to submit your mini design project. So some students have had trouble with, only submitting the updated files. So in labs 1, 2, and 3, we kind of built on our progress every time. Lab 1, we built the cabinet. Lab 2, we started adding doors and hinges. Lab 3, we added a new cabinet. And the issue with that is that when you guys start to build these more complex assemblies, you have to remember that the assembly still references material from your previous labs. So if you've made, say, Lab 3 mini design project, which had, a combination of Lab 1 parts, Lab 2 parts, Lab 3 parts, but you're only submitting the new Lab 3 parts, the assembly can't be opened. Because what's going to happen when you open the assembly, it's going to be missing parts, right? Like if you were to look in your assembly, here, I'll pull one up just to show you guys. If I open up my cabinet assembly, right, and I'm sure you've all seen this by now, in our tree manager here for the assembly, we'll have all the parts, right? Now, if I was to, say, not include cabinet shell 2, because let's say, and we know this isn't the case, but let's say this was a Lab 1 file, and all I did was submitted my Lab 3 files, then this part here wouldn't be in that. It wouldn't be in the assembly, and when the TA or whoever's marking your assignments, when they go to open up the assembly, it's going to be missing part files. So that's a huge concern that we've had, especially with Mini Design Project 3. So my advice to you, there's a feature that you can use called Pack and Go. Okay, so if you go up to File and click Pack and Go, you'll see here it loads all of the features, all of the parts, all the drawings. If you check Include Drawings, it'll load everything used in the assembly, and it can output it to a folder or even to a zip file. So this is my suggestion. If you're confused with your saving architecture, if you're confused with where you save your parts, use the Pack and Go feature, which will output everything. It makes a copy, so you don't have to worry about the original files. It'll make a copy and place it in a new location, and then you can just create an archive, either a zip or a raw archive, and then submit that on Blackboard. But anyways, back to Lab 4. So we've created our pivot block, I've saved this, and now I'm going to move on to the handle. So File, New, Part, and I'm going to sketch on the top plane again. I'm going to create 2 circles, one there, and you know what, I'm going to show you guys something else that you can do as well. So you can offset an existing entity. So the 2 circles are supposed to be 50 millimeters diameter and 40 millimeters diameter. So I know that that's a difference of 10. So just right now, while it's nice and clear, we have our original circle. I clicked offset entities. Now it's going to offset that line and create a new line. So I'm just going to select 10 millimeters as my difference in offset. You can see that right there. And now I will smart dimension the outside. So we'll make that 50. So now I have a 50 and 40 millimeter. And if I, oh, my mistake. It should be a 5 millimeter offset. Let me just quickly adjust that there. 5 millimeter offset. There we go. So now I have a 50 millimeter outer circle and a 40 millimeter inner circle. Now I know in the lab manual it doesn't have these steps listed. It just asks you to draw the 2 circles. I'm only showing you this now because you will have to use offset entities later on in the lab manual, and it's really easy to visualize it here where all we have is a simple circle. But all the offset entities does is it just takes an existing edge or line or feature and it offsets the geometry. So here I had a circle, it offset it to create this circle here. Now my mistake was I selected 10 millimeters as the offset depth, which would have been a difference of 20 in the diameter, so I just had to halve that to 5, which gave me a 40 mil diameter. Okay, I'll exit the sketch. Now I'm going to extrude this by selecting the sketch, going to features, clicking extruded boss, and it'll be 1000 millimeters. So 1000. Okay, now this is going to be very long, but that makes sense because this is our handle, right? I'll go back to this line here, So I want to select my top plane, okay, which is at the beginning face here. I'm going to create another sketch. Alright, so here's our top plane, and we're just going to create a line. So I'll just draw a simple horizontal line. Okay, now if you look next to my cursor, you can see as I drag it closer and closer to horizontal, it automatically snaps, and I have that little yellow constraint there with a line. That just means it's horizontal. You can see what I mean right here. That little green constraint right there, horizontal. You need that, otherwise it's going to cut your handle incorrectly. So I'll select the line again, and the offset for that line is 22.5 millimeters. 22.5. There we go. Okay. The length of the line doesn't matter as long as it enters one side of the handle and exits one side of the handle. Because what you're going to do is you're going to use this line as a profile to cut through the handle to make a flat base so that we can later mate the handle onto the pivot block. Okay, so I'll exit that sketch. Now I'll just zoom out here. You guys can see here's my sketch over here with the line. I'm going to select the sketch, go back to features and extruded cut. I'll select through all both, okay, just so it cuts through. And then I'm going to select flip side to cut. So you can see here I've got this arrow that's pointing in the direction that it's going to cut in. So right now if I was to create this cut, you'll see here it cuts basically everything I didn't want to cut. And if I go back and edit that feature and I flip side to cut so that the arrow is pointing down, it's going to cut everything below the line, which is what I want. So there you go. There's your handle right there. Now we can save this. So file, save as, make sure it's in my new Lab4 folder, and we're going to call this the handle. Okay. Now we'll move on to the next part by selecting file, new part. Okay, once again, pretty simple. This is just a revolve. To do that, we'll select the top plane. Sorry, my mistake. Wall casing is even easier. It's just a simple extrusion. So we'll select the top plane, create a circle again, and another circle inside of it. So we're creating a tube. I'll smart dimension the inner circle. That's 90. I'll smart dimension the outer circle. That's 100. And now I can exit and go to features, select the sketch and extrude, and set that to 400 millimeters. Okay, and that's the casing of the well. Okay, so the next part we're going to do is going to be a revolve feature, so I'll put that in a separate video because I think I've gone on long enough here. You know, like I said, if you're having problems with these parts, practice. You should know by now how to make these simple extrusions and extruded cuts. The only difficult thing that we might have done was the weird single line cut that we used in the handle, but even then it's not very difficult to do. You should be able to do that pretty easily. If, like I said, if you're having trouble, practice these, follow the videos, follow the lab manual, but make sure by the end of this lab that you are very comfortable with how to do these simple features.